Okay, so we're going to check out the second fundamental theorem again. And if you look at the picture, you're almost like, this is the same problem as yesterday. But we're going to look, this one's a little bit tougher than yesterday. And I just want you to be able to see one of these and practice with the second fundamental theorem again, because it is kind of a tricky thing. So if you remember from yesterday, we're going to be finding these things, and remember that g of is you're plugging in for x, and so if you plug in, for example, 0, you are going to have g of 0 is equal to, I'm going to plug in a 0 for every x, so 2 times 0 plus the integral from 4 to 0 of f of t dt. And so I'm going to use the area under the curve. So if you remember from yesterday, I'm going to split this. We can find these areas. Obviously, if you hadn't done the problem already, you would take the time to do triangles and figure out those things. But we did that yesterday, so I think we're good on that part. So g of 0, well, 2 times 0 is 0. Now you have to be careful here. When you do the bounds, remember that whole above the x-axis, the integral will be positive, and below the x-axis, the integral is negative. Remember, that's when your bounds go low to high. So it helps my brain. I can switch this from 0 to 4 of f. I just have to remember when I switch the bounds, I have to make this negative. And so from 0 to 4 would be -8, but this negative negates that, and so I end up getting +8 for my answer. All right, so let's try to do a couple more of those. Let's look at that again. So g of 8 would be, looking at this function right here and literally putting in 8 for all the x's. So 2 times 8 plus the integral from 4 to 8 of f. And for the sake, I'm going to quit writing t dt. I think we get the idea that how to find those things. So 2 times 8 is 16. Now the integral from 4 to 8, it is low to high, below the x-axis, so that would be -8. Well, I got 8 again. Looky there. You try g of 12. Stop the video and see if you can do g of 12. So g of 12 would be 2 times 12 plus the integral from 4 to 12 of f. Well, that's certainly 24. And then from 4 to 12, are you with me that that would be -4? I have 8 below, 4 above, so that would be -4. So that answer would be 20. Cool. Now let's look at the derivative. Okay, you have to be careful because yesterday we talked about the derivative, and hopefully you're like, oh, I would just replace the this f with x, and since the bottom bound is a constant, that just goes away. That's true, but you have this piece as well. So let's write down what the derivative would be. So g prime of x, I have to go down the line with the derivatives. So the derivative of 2x, of course, is 2, plus, now you're right to say that taking the derivative of that integral, you would replace with the upper bound times the derivative of the upper bound is 1. And since the bottom is a constant, you know that's going to go away. So yes, my derivative is 2 plus f of x. And remember, this is the graph of f. Okay? So you've got to be very careful that in this particular problem, is f the same as G prime? No, it has an extra little piece in there. So we have to be careful when we're finding the derivative. Let's think about what we would do. I'm looking at now this function, and I'm saying, okay, if I want to find G prime of 10, that would be 2 plus f of 10. Now for this part, do I look at the graph and get the y value? Absolutely, because that is the graph of f. So I would have 2 plus f of 10. I'm looking right here. I'm looking at that y value, and I get a y value, or excuse me, I get an answer of 3. You try those next two with G prime of 4 and G prime of 6. So this guy would be 2 plus f of 4. So that would be 2 plus f of 4, I'm looking right here, is negative 4. So I get an answer of negative 2. And finally, G prime of 6 would be 2 plus f of 6. F of 6 is negative 2. So 2 plus negative 2, and I would get a value of 0. Perfect. Now the last one. The last one says G double prime of 2. Well, let's look at this G prime of x. Well, if that's G prime, what would be the derivative of that one? Well, the derivative of 2 would go away, and the derivative of f would be f prime. Do you agree? So G double prime is the derivative of this graph that I have. So the good news with this one, like if I'm doing number 7 here, G double prime of 2, well, that's really f prime of 2. You have the graph of f, so you would go to this value, and what are you looking for? You are still just looking for the slope at this value. So if I go right here, what is the slope of that line? Of course, I can just read off the graph and get negative 1. G double prime at 8, I have right here. The trouble is that the derivative from the left and the derivative from the right are not the same, so you would put does not exist. So again, it's similar to what we did yesterday with that extra little piece in there. You just have to be a little more careful, write your formulas, and you can do it. Now number 9, oh, what a good one. What a good one. Okay, at what x does g of x have an absolute min or absolute max on the interval 0 to 12? Okay, I'm going to erase all the things in my picture to kind of clean, oh, that's not erased, to clean up everything. So we're looking at a clean picture. Now let's read that again. I'm looking for an absolute on a closed interval. So an absolute on a closed interval, what should you be thinking of right now? Hopefully you go, oh, that's candidate's test. Now think about what the candidate's test, what your process is. Well, you have to identify the candidates, right? The candidates are your endpoints, so that's easy, 0 and 12. But remember, not that you have to write this down, but remember, candidates are going to be, I'm writing it down so that you remember and have it in your notes. Candidates are endpoints, which that's easy, right? 0 and 12. Or when the derivative of this, when g prime equals 0 or g prime undefined. Okay? Or in other words, the critical points of g. And remember, the critical points of g are when its derivative is 0 or undefined. So let's go back. Notice that G prime is this equation here. So what I want to know is where is there a place where 2 plus f of x is equal to 0. So I've already defined G prime to be up here. So it's okay. I've got that named in my problem, assuming this is all together. So I need to set the derivative of G prime equal to 0. Well, that means that f of x, is there a place where f of x equals negative 2? Well, let's go back to my picture. Remember, this is the graph of f. So is there a place where the graph of f is negative 2, has a y value of negative 2? Well, yeah, there's a couple places, in fact, because negative 2 is right here. So there's 2 places, when x is 2 and when x is 6. So I have x being 2 and 6. Now, is there ever a place where 2 plus f of x is undefined? Well, no, because f is defined between 0 and 12, so nowhere this is not going to give me anything because I don't have any places where that f is undefined. So G prime is going to be defined everywhere between 0 and 12. So what we just figured out is we figured out that our candidates, I've defended why they are candidates. I have 4 of them. I have 0, 2, 6, and 12. So in my chart, remember, on the left I have my candidates. And what goes on the right? What goes on the right is what I am maximizing. Well, I'm trying to find the absolute max or min of g of x, so I have to find g of x. Now, a lot of times with AP, they do kind of refer back to problems you have already done. So if you notice, if I'm looking for g of 0, do you see that in number 1, I've already found g of 0? I already found that g of 0 was 8. So I can just copy that down. We've also found g of 12. That was 20. So always look back at your problem. I just copied, we've already done g of 12 there, and we did g of 0 in number 1. Now, unfortunately, I haven't done 2 and 6, so I have to think back of how I got that, and let me find those particular values. So g of 2 is going to be, let's go back, remember at our very beginning, I'm going to write it down here at the very top of the page so I don't have to scroll up, is you have this equation. So if I'm finding g of 2, that would be 2 times 2 plus the integral from 4 to 2 of f. Okay, well, let's think about what that would be. Of course, that would be 4 plus, now this integral, let's think about this one. I do have to look at my picture. I do like opposite. So 2 to 4 of f. Let's go to my picture. If I'm trying to find the integral from 2 to 4, I'm trying to find the area of that shape right here. So I have a trapezoid, kind of running out of space here. So let's see if I can fit it in. I'm going to have 4 plus, and I think that are you in agreement with me that this integral would be negative, but combined with that negative, it's going to be an overall plus there? Because again, 2 to 4 is below the x-axis, so the negative negative makes it positive. Now I have a trapezoid. Base 1 is 2, base 2 is 4. So I take the average of the bases. So base 1 plus base 2, what did I say? 4 plus 2 divided by 2 times, and then my height is 2. So I end up with, I get 6, 3, I get a value of 10. Now I have to do 6, so that would be 2 times 6, nope, not 16, 2 times 6, got ahead of myself there, plus the integral from 4 to 6 of f, so that would be 12 plus, let's go to my picture again, I need the integral from 4 to 6. Well, isn't that the same trapezoid that I just figured out? And that has the same measurements. That's kind of nice. So this would just be a negative 6. So 12, I am going low to high. So it's below the x-axis. So I have negative 6. And so I get a value of 6. And at this point, once I have done that, those are my candidates. I have looked at the y values. I am comparing 8, 10, 6, and 20. I read carefully. Notice it says at what x, so it's just asking me for the x values. So I'm going to write, you have an absolute min at x equals 6, and you have an absolute max at x equals 20. Nope, at x equals 12. Okay, and sometimes I put on the intervals 0 to 12 just to say that's not always. Again, I just kind of answer the question in a complete sentence. The AP is very big on interval notation and saying that the intervals, so I a lot of times say that. And so again, notice that on that one, it did ask for the x value. Sometimes they say, what is the absolute max value? And of course, if I had asked the absolute max value, you would have said these values, 20, and this y value happens to be the same as the x value, but that's where you would get it. So again, make sure that you are reading the question carefully after doing that work. You want to make sure that you are answering the question that was asked. All right, last one. At what x does g of x have a POI? Well, let's think about what I have to, my justification. G of x has a POI when what? When g prime changes increasing to decreasing, or vice versa, right? So let's look back. What do we have about g prime? Remember with our graph, let me erase all this again to kind of get a fresh look. This is the graph of f. Notice we have g prime. If I wanted to graph g prime, it would be f of x, which is this graph, and I would move up 2. Think of the vertical shift of 2. So it would change the y values. It's almost like I would do this. I'd go up 2, I mean, you get the idea. I'd do this, this, and this. So I changed the y values, but I don't really change the x values. I mean, the shape of it is the same. So even though it has this 2, if I want to see where g prime is changing from increasing to decreasing or decreasing to increasing, well, where is that? At what x value? Notice it says at what x value. So on this graph, I'm changing from decreasing to increasing at x equals 4, and then I stay increasing after that. So the only value that I have a POI would be x equals 4. All right, so that's good one. So AP. So work again on the second fundamental theorem, get some more practice on that, and you will be good to go. All right, peace out, peeps.